So what we hoped to achieve was the integration of the learning areas of STEM, so science, technology, engineering and mathematics. For the flexible learning, we wanted our students to be able to identify and define problems. We wanted them to research solutions and then apply prototyping and testing of their solutions as well. So we were trying to enhance STEM education through rich and relevant learning contexts, and to do that we've partnered with the City of Whittlesea, in particular Dr. Lascaris, who's the Sustainability and Water Management Specialist there. And the purpose of that is that they become our client and students design their solutions for a real-world context. In this case, it's their local community.
So one of the problem sets which we wanted to get the students to work on was how to create affordable housing, and especially as we go forward where energy costs are going to be a lot higher, we want to create very energy efficient housing. And that housing also will have need to be powered using renewable energy. So that's also a very important component of these new housing developments.
Working in this project with the principles of PBL helped us to think about flexible learning, collaboration, and rich and relevant learning contexts. In particular, we tried to apply the flexible learning principle, and we did that through setting up projects without a predetermined outcome. So for example, with a tiny house, we wanted students to have a driving question. So how might we build a tiny house that maintained a constant temperature and did so with using the least amount of energy? And for the greenhouse, students were tasked with how can we automate food production by constructing a greenhouse and then programming it to automatically water the plants. So they needed to develop variables for their project so that they could test them in a science inquiry process. So the variables for the greenhouse, for example, could be the soil moisture, it could be the air temperature, and then they would develop digital solutions to automate the greenhouse. And the variables for the tiny house would be something like the color of the house, insulation, the eaves, how the roof and shading could affect the temperature internally, and also thermal mass. In terms of the principle of collaboration for PBL, we wanted our students to work collaboratively on their projects. So we wanted them to problem solve together. We wanted them to think critically together about what solutions they might need to develop. And we also want them to then test and evaluate their solutions. We wanted students to be working on a project with the City of Whittlesea as our client, so that they could see that their work was going to contribute to a solution for sustainable cities.
And I guess by researching these difficult or challenging social problems, the students through experiment and design come up with a much better understanding or vision.
And since their impetus was the Sustainable Development Goals from the United Nations, taking those global goals and making them local was a way to make them relevant and rich.
The data is real, so they're not just fabricated data or examples from a textbook. These are experiments which they can design and build and test, and I think because it's real data from real experiments which they're doing which have larger real-world implications such as housing, I think they're very engaged. This seems to be the much better path for them to be on, I think, to tackle these recalcitrant problems for the future.
If we had not been part of the project, I believe that we would not have had these principles to aim for, and I believe that the principles helped us to organise the curriculum and the pedagogy and the projects and make them more relevant for the students. We learned that students need a facilitator. They need a guide on the side rather than a sage on the stage. They need to take ownership of their work and their problem, and they need to actually be the ones who are solving the problems. We also learned to not solve the problems for them. Through applying the principles of PBL in our STEM class, we're hoping to develop lifelong learners who look forward to embracing the challenges of the future and contributing in a constructive and positive way to their communities.